Hey,
Oh,
do you see that he fixed our score?
Oh, he
oh, did
did?
he?
Yeah.
Well, that's
Was
good.
that?
Did you email him or did he just do it?
Yeah, actually I feel really bad. I was kind of rude on the email.
Oh, well, anyway, we're recording, but that's too bad.
Oh yeah. Well,
Um,
if he's watching it, I'm sorry. I was just kind of blunt. I don't know. I feel bad.
I'm sure it was okay.
I
Yeah.
hope he's not mad at us.
So, do you want to just quickly go over part one?
Yeah, let's do that. Can we?
Yeah,
Is that
that'd be
okay?
good.
That's
Yeah.
fine. So, it just asks which type of graphs out of the four we want to use for categorical data. So, data that cannot be described by where did Jeremy go?
Am I here?
Your face isn't.
He's on mine. I see it.
Oh,
Am
maybe
I?
it's me. Okay, so anyway, I put pie charts and bar charts.
Yep.
For number two, when given a sample, what is the formula to compute p hat? So p hat equals x divided by n. N is the same as it's always been. It's the total number of cases, and x is the number of the variable that you're looking at.
Yep.
Um,
What is P? Is P the mean?
p hat is the um, what is it?
Let me read the
It's the proportion. It's
For the population,
the
right?
entire population.
proportion of the population you're observing.
That's what p is. Or no. You're right. That's what p hat is. You're right.
Okay.
So p hat equals the population proportion, or the proportion of the population you're looking at. That's
Yeah.
it. Standard deviation equals p hat, which is p hat. So it equals the square root of p times 1 minus p divided by n.
Yeah.
Yeah.
So it's kind of similar to what we've already done.
Yeah, it's not bad.
Very close.
Yeah, it is.
And then 5, we've already done this in previous, but categorical, you divide the total population into samples, into groups. And then for quantitative, it's basically anything that can be divided. So if it's numerical, it's quantitative.
Yeah. That makes okay.
That's just how I keep it straight in my mind. If you can divide whatever they're talking about or times it, then it's quantitative.
That's really smart, Nate.
Yep.
So part 2, you opened up this Excel spreadsheet and it gave us a list of the grades broken down in a class. So freshman, sophomore, junior, senior. So you're supposed to create a little side. How I did it, at least on Excel, was I created a little side 2 columns, and I put freshman, sophomore, junior, senior, and then I created the equation count if,
Yeah.
and then it does it. You can break it down for freshman, sophomore, junior, senior, and it just counts how many are in each grade. And then when you finally get that, you highlight the entire thing and you go up to the top where you do pie charts, and then the next one's for bar graph.
Where did you get this Excel spreadsheet?
It's
a
on
file.
the list of them. You know the
It's in that
list.
folder.
Oh, it's in that folder.
Yeah.
Yeah, where he has all of them saved. Any questions on those?
I have a question on.
I get that now.
On
I
what?
see what I'm doing.
I was gonna say 8. I don't really understand what the descriptors are. I don't know what we're trying to describe, really.
So I didn't either, but in the movie or on the
The video thing.
Yeah, the tutorial at the bottom, like if you, it's below where the preparation is.
Uh-huh.
Video tutorials. If you watch that, he says there's a lot. He doesn't say what all of them are, but then he says that some of them that you could do would be like the P-hat for freshmen, the P-hat for sophomores, the P-hat for juniors, and the P-hat for seniors.
Okay.
So all those percentages.
Yeah.
And then another one you could do was to create vertical graphs or vertical lines and have one section be class, one section be count, and one section be proportion. So it's the same information just in a different form.
Okay, yeah.
So you do like freshmen in class, count would be 8 people, and the proportion of that is 4.4% of the whole.
Yeah, yeah. Okay.
Yeah, that's just what he did. It's pretty simple. But yeah, I didn't know what he was really asking either. First.
Okay, cool. Thanks.
You get that, Jeremy?
Yeah, I'm gonna go back and do it.
Okay. Are we going way too fast?
Say again?
It just takes a second. But anyway, so 9 was really the only like legit problem.
Question. Yeah.
Yeah. So 7% is the true unknown percent of the population that do not have traditional phones and instead rely on cell phones. So 7% is the P value. Suppose a random sample of 750 telephone users is obtained. What is the probability that more than 60 phone users in the survey use only cell phones? So for A, it asks what are the mean and the standard deviation. The mean is just the 7% that they gave us. And the P-hat is figured out by putting it into that equation. And it ends up being, I got 0.0093. I got somewhat different, there were different answers on the video tutorial than what were on the thing.
Yeah.
So, but they're fairly close.
Yeah.
The answer on the answer sheet was 0.0099. I got 0.0093, but I don't know why there's a difference, but there was a difference.
Okay.
As long as you're doing it right with the equations, then
yeah.
Be at fault for that.
For B, state the problem in terms of the variable, which is P-hat. But P times P-hat is greater than 60 divided by 750. So 60 divided by 750 is 0.08 or 8%.
Yeah.
You guys get that?
Yeah, I get that.
So it's just stating the problem. What's that?
No.
Okay, for C, pretty simple. It's just says draw a picture and shade the desired area to describe that. So you would just, since it's greater than, you would just find the 8% line and then shade to the right on the normal curve.
Yeah.
For D, says convert or standardize the values of p-hat using the standard normal variable z. So you're basically just finding the z-score. And the z-score on this is the value that we're testing minus the mean divided by the standard deviation. So it's 0.08 or 8% minus 0.07 or 7%. And that's divided by 0.0093. I got 1.075 on the thing. It was 1.073, but again, I don't know why. I'm gonna put my screen down here. On E, I'd find the area under the standard normal curve using the applet. So you just put the z-score in the applet and shade to the right. And the area was 0.1412, or 1416.
Yep.
And then to interpret the area, I put it just represents the probability that the sample has more than 8% cell phone only use households. Kind of a tongue twister, but they said there is a 0.1416 chance that more than 60 phone users in the survey only use cell phones. Kind of makes a little
Yeah.
sense.
Cool.
Does that make any sense, guys?
Oh yeah.
Yeah.
Well, yeah.
Okay.
For the most part.
Questions? We can go back. We got time.
I only had the question on 8,
Mm.
the descriptors, but other than that,
I just need to go read the chapter. I failed this week.
I wish he would have told us like what's the definition of a descriptor. I mean, I don't know. It just describes what you saw, but it seems like there's infinite amount of things that you could write to describe data.
okay. Yeah, I didn't read anything in the reading, so I was like, what? I didn't understand really.
Any other questions?
Nope.
Should we take the quiz then?
Let's do it.
Good.
I'll be riding upon your guys' backs, but whatever.
Well, pull up the chapter.
I have the lesson. I've been reading it as you guys have been talking about it.
Oh, okay.
Or at least I've been trying to follow along, see the formulas you guys are talking about and all that stuff. Whatever.
Okay. You want to click
Okay.
stop on the
I'm gonna
report?
stop the broadcast.